Good evening. Welcome. I'm going to do a quick sound check here. Hopefully everything's working. Mike, I see you there. All right. Thanks so much. Thank you for joining our TI Technology webinar hosted by Texas Instruments. Tonight's session is The Enchanted Beans, Sampling Distributions and Inference. I'm Ruth Casey and I'll be the host. Throughout the webinar, we'll be using the WebEx chat panel to share comments or ask questions. When you use a chat, please select everyone from the drop-down menu. And let's go ahead and give that a try now. Maybe give a shout out to everybody. Tell us where you're joining from this evening. As a reminder, the session is being recorded and will be available for viewing or reviewing the presentation. If you experience any audio or video issues that can't be resolved, please feel free to just watch it later after you get the link for the recording. At the conclusion of the webinar tonight, we'll give you a link for the certificate of attendance. You'll also get this information in an email in a couple of days. All right, thank you for chatting out your locations there for us. Other interesting data might be, what's the temperature where you are? Again, thanks everyone for being here. We are fortunate tonight to have two outstanding educators with us. We have Mike Houston and Tracy Wilson. My names are backwards from your picture, so I almost messed up. All right. Mike, Tracy, tell us a little bit about yourself, what you do when you're not doing webinars for us.
I'm Tracy, and I am currently in Athens, Ohio, an assistant professor of instruction at Ohio University. But I am still fortunate to work with a group of AP statistics teachers from Arkansas. I just moved here from Arkansas after living there for 27 years. So I'm still working with this group of teachers that I met a couple years ago and just having a blast doing statistics.
And I'm Mike Houston. I teach algebra, calculus, and I'm a new statistics teacher. I've only been teaching stats for 2 years. I have some AP stats students and some elementary stats students. So I'm really excited to be here because I've already learned a lot from just working with Tracy over the past couple weeks preparing this. I teach at a small rural school just outside Pittsburgh. And again, I'm excited to be here.
Thank you. Thank you both. And thank you everybody for attending tonight.
So we've already started doing some of these welcome and introductions. Again, thank you so much for being here. We're really excited to have you. We're going to focus tonight on Lima bean activity. It's going to kind of walk us through this idea of sampling distribution. The good news is that even if you maybe don't use this Lima bean activity, there's lots of other ways that you can create sampling distributions. And so we're going to have some of those other ways available to you as well. So if at some point you feel like you're sweating because you haven't, have enough Lima beans to do this, don't worry. Stick around to the end because Ruth is going to be giving away to one lucky winner a TI graphing calculator of their choice.
So we hope when we finish tonight that you'll be able to say three things. I can simulate an approximate sampling distribution using a variety of tools. We're going to show you three different places that you can go to do it. And we hope that you're going to be able to know how to construct a confidence interval using the TI-Nspire and also run a significance test because inference is big in statistics. So I think I'm ready to share my screen. Am I right? Keep me honest, y'all. Oops, it went away. There it comes. Okay, can you see my screen, Mike?
Yep, looks good.
All right, awesome. So the first thing I'm kind of curious about is, I'm assuming everybody here is a statistics teacher or wants to be a statistics teacher, which should be every person in every math teacher because statistics is just awesome. And I'm curious as to, by the time December rolls around and starts passing your way, where are you in your curriculum? Now, I know we are probably not all AP statistics teachers, but the AP statistics curriculum gives us units that we follow. And every statistics class addresses these issues. So I'm just kind of curious if you don't mind putting in the chat kind of where you'll be at the end of December. I know we're at the beginning, but I'm just kind of curious of where you're going to be ending up as you roll into the new year. Like I said, I work with a group of 7 statistics teachers. They're all over the place. I have one that will be finished the whole course because they do it in one semester. I have another that will definitely get through Unit 5, get through sampling distributions because she starts at the beginning of August. And then a lot of my other ones will be somewhere in Unit 4. Um, Mike, where are you going to be?
Yeah, fingers crossed. I'm hoping to be on sampling distributions. I'm definitely moving at a little bit of a faster pace this year than I did the past 2 years. This again being my third year of teaching AP stats. So yeah, hopefully sampling distributions, I feel pretty good about that. We're seeing a lot of other people in that sampling distributions area. I think I saw a couple that would be finishing up probability, so kind of right on the edge of that. Um, Someone with a 1 semester course ends with hypothesis testing.
Yeah, and so I mean we're all over the place. And I mean it is what it is. If you're an AP stats teacher, you always complain that the test is too early because you could always use more time. But one of the things that I always stress to my teachers is the sampling distribution idea is so important for inference. To me, if I had to describe statistics with one concept, it actually wouldn't be inference methods, it would be sampling distributions. Because that's the crux of why we are able to do inference methods. Um, and so that's kind of, what my little mantra is that, and I tell you, the first couple years teaching stats, I did not realize that. Oh no, I was just trying to get through the curriculum just like everyone else when we first start teaching, just trying to survive and get things done. But I think the further you go, the more you realize how important the understanding of sampling distributions are. And so that's why when we were talking about what to do, I thought that idea is so incredibly important. Um, Mike, if you talk to people about what your statistics class is, what do you tell them? How do you describe it to them?
I'm going to steal my answer from Steve Phelps because he said it to me the other day, and I was like, yeah, this makes sense. He said, you're really telling a story, right? And so I was like, okay. So I thought about that for a second, and I really liked kind of how that described a lot of times what we do in statistics. And for me, my students, the biggest hiccup near the beginning of the year that I face is my students think that we're going to prove something that we can say, oh, this is for sure going to happen with statistics. And it takes a little bit of time to kind of walk that back.
Yes. So many math classes, there is an answer. And you write equals this. Statistics, whole different ball game. And I love that you said it's telling a story because it is all application. It's after they get in the class for a couple weeks, they like this is not a math class. It is, but we talk about all the context of everything is so important. So what I want to do is I want to kind of describe to you first an activity that I offer my teachers. I don't tell my teachers what to do. I just offer a lot of stuff to them, give them ideas. I give them curriculum, but they can do what they want with it. I'm not one that's going to say you have to do something this way. And one of the activities that I have my students do, I suggest my teachers do is start collecting data from day one even if you don't know what you're going to do with it or what you're doing yet, because all the beginning of the course is figuring out how to work with data and talk about data. And so I'm going to describe this activity that a few of my teachers started off the year collecting data. I had a couple of teachers that admitted, nope, I didn't do it this year. And that's okay, because I still think even if you just do it in a a little bit before you start sampling distributions, or even after you've started sampling distributions, to get the hands-on activity for sampling distributions, I think is extremely important. So here's my activity. This is not my idea. I found this on a Facebook post. I tweaked it a little bit. In my slides that you will have access to, here's a tiny URL that you have a folder with the slides, and everything that we've got is there for you. And so what my teachers do is they're given two lima bean populations, population 1, population 2. This teacher actually put dots on so that she could tell the difference between the two. And just so you know, these cards here, the teacher I asked to take a picture of actually listed the population values, because I told the teachers how the population was made up, but my students shouldn't know at first. So I had to kind of do a little Photoshop and get all those values off, because I didn't want her to have to worry about taking another picture for me, because it was a really good picture. And so at first, just looking at these two boxes, even with having like a little couple of beans out here, can you tell if there's any difference between these two populations? The beans have numbers on them. You can tell that by this little group that I have in front. And so somebody says, yes, you can tell there's a difference. What difference do you think is between these two populations, and how do you know?
I
And if
see
you have any
one
thoughts,
population
put them in
is a red dot and the other one is a green dot.
chat. Yes, the
I
different
don't know if that's
colors.
going to really help. Yeah.
One's labeled, so we know I must have two different groups of lima beans. Now, the lima beans have numbers on them. Do you think the numbering of those two populations of lima beans is the same? And do you think there's the same number of lima beans in the two boxes? Can you know? We got a bunch of no's. It wouldn't make sense to have them to be the same. So your instinct is saying no, but I actually like what Samuel's saying. Just by looking, we're really not sure. Mike, can you tell me how many lima beans are in the green box?
Yeah, hold on.
Oh no, you're not allowed to look anything up.
I don't know. It's like how many marbles are in the jar kind of thing.
Yeah. So, I mean, we don't just from looking at a population from a distance as this big group, we don't know a difference between the two. And as a statistician, we don't want to look at everything in our population. Someone guessed 474. Not quite right. You're kind of close on one of them. And so just a statistician doesn't want to have to look at every single lima bean. This is why we talk about distributions, looking at them. But then when we do statistics, we just take a sample and do work with a sample. And so the very first day of class, we have a student, two students, or the same student, take a scoop out of each of these, take 10 lima beans from each box. Now, this is an image. This isn't the actual lima beans. They're white in the box. I didn't think white lima beans would show up on my slide here. And so I've got these two different samples from these two different boxes, the red box and the green box. One of them I called population 1, the other one population 2. I can't quite tell which is which from this distance. Now looking at the sample, can you say anything maybe? Are you smarter about the populations? What do you think, Mike?
I think if we took a good sample, I could maybe start saying some things about the difference between the populations.
Okay, what do you mean by a good sample?
I mean, I talked to my students about proper ways to sample. So, like the big thing that we always talk about is you have to take a random sample,
Mm-hmm. Mm-hmm.
right? And so I want my students to kind of like not work too hard, just reach in there and just grab 10 lima beans out without looking at the numbers.
Yep. I suggest them to mix them up. Lima beans, when you buy them at the store, they're not all the same size. So this is not perfect. They should be all the exact same size to have equally chance of picking all of them, but it's still a great hands-on activity. So I tell them mix them up first, makes a little noise, and then pick the 10 out to get the best possible random sample. So that way we would ensure it is, oh, I like the wording that Jose says, it's representative of the population. Now, Jose thinks the right is not representative of the population. But I can tell you that these two samples were as best of a random sample as we could take. The boxes were really mixed up and we picked out one at a time, okay? This is a sample that one of my students took, okay? Now, what we do at the beginning, other than that, we really don't talk about this. We just, okay, now tomorrow I'm going to have you do it again, okay? One of the things, I do have them make a calculation for this. I have them calculate the mean or the average for their sample they pulled out. This less sample, I'll move this box out of the way, has an average of 2.1. Students do not really need calculators to do this. This is why I chose 10. So they can add these numbers up, which I kept pretty small, and then divide by 10, so they're just moving a decimal place over. And the sample on the right has a mean of 0.9, okay? So from this, you have a little bit more information now about these two populations. Do you think those populations are the same or different? Put something in the chat. Same or different? Or roughly the same or roughly different? I guess we should do the wiggle room, that statistics. We got
So
some
far, we got
thinking
roughly
different. Roughly, yeah.
probably different. Let's see
We're
if
kind of
anyone,
getting an inkling that they are. Because
yeah,
those,
a lot of difference.
yeah, a lot of difference. As a statistician, are we certain that they are different? Oh, someone wants more information. Just by one sample of each, it's not enough. Now, later on in the course, we do just take one sample and make a conclusion, make an inference about it. Now, we're not at this point yet with our students, even if we've started sampling distributions, but you get them to kind of think about it. Are you certain? Would you, I don't know, whatever's important to them. Would you spend a whole Saturday with me doing math, make a bet on that? You know, if you lose the bet, then you have to spend an entire Saturday and do math with me. Well, some of my students would say yes because they like math, but now what I have asked my teachers to do if they're going to do this up front is now every day from August to now until they hit sampling distributions, they have one student do this every day. Shake up the populations, pull out 10 lima beans and calculate the mean. Add them up, divide by 10. And they put that information on posters. So here are the posters from two of my teachers. They sent me pictures of them, of where their stage is right now of pulling out 10 lima beans from a population and calculating an average. So on the left is from one school and on the right is from another school. Now, students get excited. They're seeing this building every day. Imagine all they're doing is they can calculate an average, pulling some beans out, do an average and put a dot. I do recommend when you do the whole sticker dot thing, write on the dot the average. So that way, if someone puts it in the wrong spot, you can get it in the right spot for them after they leave. Now, when you reach the area of your content where you're going to ready to start talking about sampling distributions, look at your poster and have students talk to you about your posters. What do you notice? What do you wonder? So here again, these are two real live posters they just sent this to me a week or two ago of what my teachers have built in their classroom. After students have gone through the beginning of the content, what are they going to notice and wonder? I want you to think like a student now. You've learned how to do one variable statistics, two variable statistics, probability, distributions, dot plots, histograms, all this stuff. How do you talk to them about looking at something like this statistically now? What are they going to notice? And then I think the big question is, what do they wonder? And if you put your thoughts in chat, that would be great. Mike is going to try and collect them on the next slide. So that way, again, you'll have a record of what we talked about tonight, so you can go back and look. So a student is, hopefully at this point, we'll talk about the shape that they're seeing. Now, we know what's happening here, but can you imagine seeing this built? We can see my teacher on the one side has more dots than the other. She started much earlier. She's the one who started in August. My other one started late August, so she doesn't have as much data yet, but you can still see something building. Somebody said normal and someone else said bell curve. You have talked about the normal distribution, the normal curve, the bell curve. Don't you think they're going to see this now? It's not perfect, but it seems to be approaching approximately normal. Okay? And your students, I guarantee you, will notice that even before this day that you want them to notice and wonder. They're going to start talking about, oh, this is turning into a normal distribution. Again, if you didn't do this, which if you haven't seen this before, you haven't yet, you can still get your bang for the buck just doing this for 2 weeks. Okay. And even if you're in sampling distributions, still doing this and having them physically take these samples and put a sample bean dot up is so incredibly important for them to understand what we mean by a sampling distribution. So let's go take a look at some of the notices and wonders. The distribution of sample means gets closer and closer to a symmetric distribution. I like that. They should be talking about the shape, what they're seeing. If they mention normal curve and bell curve, you know they're kind of seeing what we are hoping will happen. Population 1 is more right compared to population 2. I'm going to go back to the picture for that. Notice how the top is my population 1, and it shifted to the right more than the left, than the one on the bottom. This is having it vertically, which in the classroom, we usually have them side by side because we don't have enough room to have them vertically. I put it vertical for a reason, to see if they would see that. What do you think that might say about the population? Oh, we have a question. Is there any skewness?
And while we're thinking about that, just one piece of clarification. Whenever your students are sampling each day, are they sampling with replacement or without replacement?
Oh, that's a good question. I gave them a cup so they get good at scooping about 10. So would that be sampling with replacement or without replacement?
It depends on what they do after they count their beans.
They scoop out, I try and get them to scoop out 10, like in just one scoop. So that I think is more like sampling without replacement. Because
Okay.
yeah, we're thinking about that whole independence condition thing.
As
Now,
opposed to like one at a time, right?
yes, and putting it back. So they could do one at a time, but don't put them back.
Okay.
So that they get 10, I want to say unique lima beans. That's a really good question. I wanted it to be without replacement. I don't know if I don't think it would matter much here for this particular experiment. Because of how many lima beans there are in relation to the size of my sample. But that's the kind of refinement that you will get if you're getting into when you get to the sampling distribution unit, that whole condition stuff. Good.
So then the 10 that they sampled, they go back into the population
Yes, throw
after
them
they've
back in.
reported, right?
Yep. Otherwise, in about 50 days, you'll be without 50 or 60 days, you'll be without lima beans. Good question. Very good question. And be careful they don't drop the boxes. That happened to one of my teachers. She said they dropped it and we got them all mixed up because then that student has to resort them out. Or I just gave her new boxes that were already done. Okay. So, one little clarification. Whenever I give my teachers an activity, I always try to decide to give them sample data of what they might see at the end. And so here is like a picture of the posters that I created. I sat down, well, I had a student sit down and do this for me. That was her little project that she did. And she did this a whole bunch of times. And I try to get her to do the whole, definitely shake it up, get as random as we wanted. And so this is what they kind of know should approximately happen. Now, there was one mistake that I made on my poster when I took a picture and I gave it to them. When I titled this, because after you do this, what do you notice? What do you wonder? Then you want to tell them what the name of this type of distribution is. This is not a population distribution that we've done. This is not a sample distribution that we're looking at. It is a sampling distribution of sample means. But I did forget one word that I'll tell you the first 5 years of teaching, I probably would not even have noticed and just moved on. But you kind of pick up little things that you have to be careful with. Wording in statistics is very important. And one of the things with statistics, go ahead, Mike. What did I do wrong? Embarrass me.
Well, it took me a minute, so I think I'm the one that's more embarrassed here. This is an approximate sampling distribution, right? Because
Yes.
we don't have every possible sampling distribution value that we could have.
Yes. I didn't write the word approximate up there. And I mean, and I even made these posters just a couple years ago. I have taught stats for 7 years and then did a little bit more for a couple more years before I did. And I even forget that wiggle word every once in a while. And so what we're building is an approximate sampling distribution.
So then,
But
can I ask a quick clarifying question?
yes,
So
yes,
you said this is not a sample distribution, right? It's
right.
sampling. So if it was a sample distribution, that would just be that one student's scoop of 10 lima beans and what
Yep.
their distribution looked like. That'd be a sample.
That would be a sample distribution. I would line all the zeros, the ones, the twos, threes, and fives and stack them.
Okay.
You can actually make a physical dot plot with the actual lima beans, and that would be the sample distribution. Oh, that's
Perfect.
cool. That's cool. So there's these 3 different things, your distributions you're working with. The population, someone asked, how do I decide the numbers on the lima beans? Again, I took this activity for somebody, I modified it. I'll tell you, spill the beans a little bit. I only used the numbers 0 to 6 because I thought if I start writing 7 on some lima beans, it might look like the number 1. The original activity used 0 to 9. And so I don't know how they tell the difference between a 6 and a 9. So, but I mean, I just made these distributions up. Now, my teachers know, and you actually will know in a minute, what the true population is and everything. Okay, now, and let's go now. And if you want to do the actual physical lima bean activity and you haven't done it yet, again, I think if you just do it next week, it doesn't take long to label lima beans. I did it in probably 10 minutes. It wasn't that bad. you can just do it just for a couple of weeks. Have all of your classes. Pull 10 lima beans out and put a dot on. Talk about advertising for your class. And they're going to be wondering, what the heck are we doing? Well, you got to take statistics to know. So, but if you don't want to do that and you still want to get the benefit of seeing a distribution kind of build up, we've got 3 places that you can go that I think are very valuable to create sampling distributions. So investigate what they are. The first one is actually using the TI-Nspire. The idea I got from one of the math inspired sites. So these are 2 active links. Okay. This will get you to the TNS file that I'm going to open up in a minute. And then this will get you the TI website, which I've got it right here already, that has all of their Nspire activities related to sampling distribution. Okay. So here's some really nice places to look for activities on the Nspire related to this. Then we'll go to an applet and then another website. But I think we're going to go to the Nspire. I'm going to use my new trick. Didn't work. Oh well. And I have my Nspire open, and you have this file. I called it the original file, but we're going to actually add to it. So if you got your Nspire handy, you probably don't have time to put your data on the Nspire, because what I did is in page 2, I have the 2 populations, which you will find in a Google spreadsheet that I have available to you. This first tab is my students' data collection she did for me. I made her put everything in the spreadsheet, all her results. And then the second tab is the population data. And if I go to the top, you'll actually see what the population sizes are if you're interested. There is nothing special about those numbers. It's just when I decided to stop labeling lima beans. So, and you're even seeing the sneak peek at the population distributions. You can see someone mentioned earlier something about skew. One of them is skewed. The other one is approximately uniform. Okay. So when I'm using random stuff on the Nspire, do you know that you should seed your calculator? Otherwise, everybody's going to get the same random numbers. Mike, what seed do you want me to use?
Let's use the last 4 digits of my phone number. That's what I've always used. 0831.
Okay. And it says done. That means if you use those same numbers, I didn't do the 0. Did it take the 0 away?
Yeah, I don't think it
Okay.
needs it.
I
I
guess
think
it,
just use 831.
yeah. Doesn't matter how many digits you use. Sometimes I type in 10-digit stuff. Just type a whole bunch of numbers. Now, whenever we run any kind of randomness, it will be random enough different from my neighbor who chose a different number. Okay. Now I pasted in these 2 populations. The first column has 527 numbers in it. The second column has 600 and something. I don't remember what it is anymore. Mike, would you mind refreshing me? What am I asking students to do? And then we want to try and do it on the Nspire.
Okay, so they reached in with a cup and scooped out hopefully 10 lima beans as a sample from the population of each bin,
Okay,
one
hold
at a
on.
time.
So do you know how do I do just that piece on the Nspire?
So I
Pick out
think
a
it's
random sample.
under, yeah, I think it's under the menu. I think is where most stuff is. And let's go under statistics. Nope,
It's
sorry.
under data.
Yeah.
The thing I like about the Nspire is you just go look.
Oh,
It's
I
in
see
your
a
menu
random,
somewhere.
see that random word.
Yeah, let's go to the random word and see what we go there.
Oh, sample, the last one there.
Ooh, random sample. Okay, awesome.
So, you know what's funny is I use the Inspire every day, and I know that everything's in a menu, and I really do like the format. whenever I do a lot of stuff in stats, though, it's stats commands are usually pretty syntaxy.
Mm-hmm.
And so I still find myself a lot of times using the catalog, which is actually why I didn't know where that was in the menu, because I went straight to the catalog and just typed the R and knew that I would scroll down to random
Okay, tell
sim.
me how do you do that? What do you do?
So go ahead and hit the catalog, which is to the right of the 9,
Okay.
and then just type R to jump down to the R's and
Ooh.
start scrolling down a little bit so we get rand and then keep going. I knew there was going to be a random sample command right there. And I like that below that it tells me, okay, so I'm going to say I need this stuff from you in order to do this command. So we can either just type random samp, I could press enter now. You could go to the menu and go to, data and go to random. But I know I need to include the list first and then number of trials and then whether or not we're going to include replacement.
Okay.
So go ahead and drop that in.
All right.
And then we have to talk about what list we're going to sample from. And so let's do pop one first. And you can either type pop one or hit the var button, either one. And then after that, we needed to know how many.
How
And I
many
think
lima beans?
they sampled 10, I believe.
10? Yep.
And then I think you can press enter. Or
Yeah.
no, you need to know with or without replacement.
Well, if you don't, and in our case, it really doesn't matter much, you can put 1 or 0 sampling with replacement or without replacement. I think in my screenshots that I put in our Google Slides for y'all, I put 1. Now, so that is that first step. I'm not going to execute it because it won't quite work yet. But that is getting the Nspire to pick out 10 lima beans from population 1. What else do the students have to do?
They had to take that sample and find the mean.
Okay. So what's the command for mean on the Nspire?
I always type it.
It is just mean. It's,
Okay.
that one's
Yeah.
nice. Yeah, just type it in front. Okay. And I'm going to
So
go
if
ahead
you
and hit
were to,
enter
yep.
so that we can see what it does.
Oh, that's and I love fractions. My students typically hate them, but I love them. But even that doesn't make me super excited right now.
Right.
I really want to see 4.1. So is there a way to just make that into a decimal for sure?
Yes. The way I know, because I'm using commands to get all of this, at the very beginning, and notice how I can come down here and edit, approx for approximate, shortcut for approximate in parentheses. Then you're approximating that calculation. And so we get 2.8. Okay. Now that's just picking up one sample. And one thing I forgot to do, I need to label my columns because I'm going to be wanting to graph this in just a second. So I'm going to label this column samples 1. Now I'm only going to do population 1. I'm going to leave off population 2 because of time. Okay. Now to get a whole bunch of samples, I like the fill down that you can actually on a computer, so it's even easier. I can pull this down and take as many samples as I want. So I'm doing what my students did physically, just using the computer to pick the random samples. And so it looks like I'm going to do 111 of them. Now to get the picture, I'm going to add a page. Data and statistics is where we do the graphical stuff. Oh my gosh. What the heck is this, Mike?
I think that's everything. That's probably all. It says caption pop one. So that's our entire population right there.
Yeah, isn't that cool?
It's wacky.
You actually are seeing the population, you're seeing the box and all the lima beans labeled. Look at all those numbers labeled around. That's not what we will look at though. But I love that. If I come down to the bottom, what variable, what do I actually want it to graph?
I think the samples, right?
Yeah, That's what our students are doing, right?
Yep.
The students are graphing our samples. Boom.
I love like that animation. I know that I'm just a techie geek, but I appreciate that
Yes, I love it too. I love it.
every time. So just for anyone that is newer-ish to Inspire, just so you know, I believe if you were to go back to page 1.2 and decide that you wanted more samples and start affecting that column B, it'll start dynamically, automatically changing your dot plot on page 1.3.
Yep.
So you don't have to like regenerate or anything.
Yeah, I can just, and the nice thing is, I mean, it's doing this so fast, I can really start seeing that building of the distribution. We're seeing a little bit, it kind of was getting like it was a little bit of skewness, but remember, I don't really have that many samples yet. Really, in reality, it's not even close to all possible samples. I'm going to really quickly, because there is something I wanted to show you, do the samples too. I'm doing the exact same thing. If I can spell. And pop 2, we're picking 2 things, or no, 10
And
things from pop 2. And I'm going to pull this down because one of the things we can do, like I did with my posters, when I stacked them, I can stack these 2 sampling distributions, no, these 2 approximate sampling distributions on top of each other on the Nspire on that page. And I know I picked a lot more samples for that one, but that's fine. Do you know how to do this, Mike?
yeah, I think so. I always
I forget
go
half of the time.
at the very top, there's like the circle var, and the split page is to the right of that, where it looks like it almost looks like a graph screen in between the var and the camera near the top, the icon.
Oh, you're going up here?
Yeah.
Oh, no, that's not what I'm thinking. I don't want to split the page. I want to put this other
Oh, you
sampling
want to
distribution.
add a variable.
Yes.
Okay, sorry.
Yep.
I think that can we right click?
Mm-hmm.
That work? I'm a right click fan.
Yep, I am too.
And then we could add another X variable. And then it's going to say, what do you want to add? And I think we want to look at samples too. By the
I
way, right click if you're not using a computer is control menu,
yeah.
because it like brings up a context menu, which I'm a big right click fan.
Mm-hmm. Now, this again is just an approximate sampling distribution, but even just looking at this, there's a difference between these 2 populations. I think we're pretty convinced. We thought we saw it from picking the 1 sample each, but this is actually, I think, really going to convince students, yes, these 2 are definitely different. Now, before we leave this, just a quick note. You can regenerate this whole thing and do samples all over again in just one little click. If I do on my Control R, so on here it would be Control followed by the R key, it actually regenerates anything on this page that was randomized. And so now when I come over here, I'm seeing a different picture. The gaps in the dots. Well, honestly, it looked like some of my students, how they made their dot plot on the posters. But why are there gaps? How do you explain that?
I think it's trying its best to like line up whatever that'd be, like 1.5 something or 1.6 something, and it's having trouble like splitting the difference between those two, and so it's just kind of like doing its best. That's how
Yeah.
I've always thought about it.
Yeah. It's that if we had better resolution, then it could be really good. But again, remember, go look back at our students. Look at theirs.
Right.
Inspire looks like my students. Now, when I did the dots, I did a much better job than my students did. And even some of them I didn't do so good on, but that's okay. Okay, we need to move on, don't we?
Yep, let's go.
All right. The other place that you can do sampling distributions is this Ross Chase applet collection. It's called One Variable with Sampling. I'm going to click on that. And Mike, do you want to talk about this a little bit and maybe just use your Beyonce data? Talk about
Um,
your Beyonce thing.
Yeah, so I thought this was really cool. So let me talk about Beyonce really quick. So if you haven't used any of the Stats Medic activities, they're free. I like using them with my students at the very beginning of the year to get my students excited about what they're going to be learning and just doing something, again, data collection. We take a look at the song Crazy in Love by Beyonce. So students are walking in, that song's like blaring, and they're just trying to figure out what's going on. And what we know is true about artists is they use the same average word length for that particular artist. And we know a little bit about Beyonce. We know that she for sure wrote all the songs for Destiny's Child. And so for those Destiny's Child songs, we can say, hey, this is Beyonce's like average word length. And what we want to know is if she actually wrote the lyrics to Crazy in Love, because there's people that think that she didn't. And so we collect some data. So I gave my students the lyrics, the entire sheet of lyrics for Crazy in Love. And I say, listen, we need to look at the mean of the average of each word. And there's a lot of words. I'm like, all right, that's going to take too long. Let's just do a sample. And so I had them do a quick sample of 5 words, and they find the mean of those 5 words length, those 5 words to get an average word length. They put a dot up on my dot plot. And so we start using that just to kind of see, okay, well, here's our quick sample dot plot from what the sample that we took. And like, how does that compare to what we know is true about Beyonce's, actual average word length? And so this is where we start talking about shape, center, spread, things like that. But also, we bring in, if you want to uncover the man behind the curtain, we have her actual word length is 3.64, and like where would that kind of fit with our samples that we took? Um, does it is it really crazy and really unusual, or does it kind of fit in with all of our dots that we took ourselves? And looking at this, it looks like it fits pretty well. And so I asked my students to think about like, what would that mean? And some of them get it right, some of them get it wrong. And I'd say, well, let's do the opposite. Let's assume that that pink dot was nowhere near the rest of our dots. What would that mean to you and tell you? And that's where we talk about like, okay, could this happen by chance, or is there something going on here? So I just personally really like this activity. And so if you've done this and you need some data, if we could actually hop back over to the Rossman chance real quick,
Mm-hmm.
because I didn't know this. You're the one that told me about this, Tracy. There's a drop down, and the Beyonce data is already pre-populated, which I thought was really cool. And so, you can actually create a sampling distribution using the Beyonce data. And so I thought that would be really neat for my students to do. I still have that original Beyonce poster hanging up in my room from late August. And so now we can go back to it and talk about, well, what happened with that? And what new words or statistical concepts can we talk about now that we have learned a little bit over the past few months?
And so what was your sample size that you did?
We did five words.
5?
Yeah.
Okay. And so this applet is just phenomenal. If I do a draw sample, look what changes on the screen.
So that was what, one sample of Beyonce's lyrics and the average word length of 5.
Yep. And so from this one sample, they give me the data. They give me the sample distribution. And look over here, here's the population distribution. but there's the sample distribution. And then over on the right, they're starting to build the approximate sampling distribution.
So can you do it more than once? Can you do it like 25 or 50 or 100 times quickly?
Yeah, I do a couple, let's say I hit 5. So now let's go ahead and boom, do 25 samples of size 5. Boom. 25 more. And what's happening over here?
I think it's building something.
Yeah, let's go ahead and do 100. Look at that.
And I love that it's still showing where those 5 samples were coming from out of the population. Like you can see it's being sampled from the population. I just think this is really, really powerful.
Huge, huge. And I'll just give you words of advice because I did not do a good job on this the first 3, 4, 5 years of my teaching. Getting them to see these 3 distributions and understanding the difference between them. Big. Population distribution, sample distribution, sampling distribution. Getting that difference is big to get across.
All right,
So
so this is just the Beyonce data,
mhm.
but they could probably do this with their own or our Lima Bean data if they wanted.
I think here's one of the Limadine data populations that I put in here. I don't know which one right now. And I'm going to go ahead and do, well, 1,000 samples at once. So that's using the Lime. You can put your own data in here by clearing and then popping it in and say use data, or use the pre-populated data. Because these all go with some activity somewhere. You Google sleep 1, you'll probably find the activity that goes with it.
I love it. All right, let's show that last tool.
Yeah.
Because that one is also, I think, really, really interesting.
Yes. Okay. This page looks scary. Just hit begin.
So it looks like we have a population there. And below that, I see animate and then like 5, 10,000, 100,000. So what? So we can take a sample from the population of either 5. No, that's the number of samples it's going to take. Right, yeah.
Here's the size.
Yep. Gotcha.
Yeah. This one's a little weird how they have things laid out, but it's still worth it. So we'll do size 5.
And you can say you want the mean or some other statistic.
And when I hit animate,
Oh, so that did a sample from the population of 5, and then it calculated the mean of those 5, and that's what that blue nugget is there.
I love the animate. Make sure you do this with your students several times slowly. So I love that they see it dropping down and then it calculates the mean. And if you want, you can have them do 5 samples and then things start popping up. This one, you can use it to talk about the center of the sampling distribution and how it relates to the population. It also gives you information about standard deviation and median. So you can have lots of good discussions here. Let's go ahead and do 10,000.
Here's my favorite thing about this site, though. If you go up to the top, go ahead and clear the lower 3,
Okay.
and then change it from a normal curve to something that is not normal, skewed or whatever. So if I ask my students what they think the sampling distribution will look like of the means, I usually get some answers that are correct and some that are not correct because this is skewed. And so I love doing this again, or better yet, having them, play with it for a little bit. Because you can even, like, it says can be changed with the mouse at the top. And so you can like click in the black area You don't even have to go to custom, I don't think.
Oh, you don't have to go
I could be
custom?
wrong. I don't think. See?
I didn't know that.
Isn't that just,
So you can
yeah.
actually create a custom.
And like
Ooh.
if so all of my students are wacky, distributions, and what would happen if, and then everybody think that's super slick.
To get across that they have to pay attention to the sample size and why we end up saying central limit theorem, you got to get up to 30 when you're doing means, is because if it's not that, here I can show them if I take sample sizes of 2 from this kind of population, this is not normal. Those conditions are really, really important. But if I pop it now up to, this site only has 25 size sample, but that's okay. That's why I need to have a certain sample size to guarantee the sampling distribution is predictable. It's predictable. That's the key. Because of the predictability of what we would expect samples, we can look at a sample we pick and know if it fits in or not. Can judge if it's unusual or not. That's why I say understanding sampling distributions, that's what unlocks the uncertainty and empower us to be confident about inference because the sampling distributions are predictable. Meet my conditions, gather my data well. I can only have to pick one data and I'll know how it behaves. We have a curve for sample proportions. That's what the sampling distribution is going to look like. We know that. And then when we do, where is it? Means, same thing. We have predictability. So that's why we're only allowed to do one sample. We only need to do one sample for statistics. We do it well. Just so you know, there's more stuff in this slideshow. Okay, we didn't get to some of the things, but that's okay. I do want to give credit to the last slide has the link of where I got the Lima Bean activity idea. I also put some other links on here. If you are following Facebook group AP Statistics, David Bach is posting some newbie tips. They are phenomenal and I'm collecting them. He's just going off and telling us tips because he is a guru and some of them are long, but they are really good to just sit down and read the tips. Oh, and at my Kroger, a pound of lima beans is $2.99 right now.
So this is expensive.
Mike, I should have asked you how much your lima beans are. Now that's only 1 pound. Arkansas, I can get a 2-pound bag of lima beans. I can't get that here. I can only get 1 pound at a time.
I honestly have not looked recently, but I will. I'm gonna look now. I mean, now I got a homework to do.
Yeah. I think we're going back over to you, Ruth, right?
All right. All right. Thank you. Thank you. A lot of good stuff going on in the chats there. Michael and Tracy will be keeping an eye on that chat, answering some more questions as they come up. So keep them coming, questions and comments in there. Okay, we are ready to have a drawing.
Ooh, what are we going to win? Oh, I'm not allowed to,
Okay.
am I?
Your choice of a TI graphing calculator. All right, so I did a random drawing while you all were doing some other randomness, and the winner is Rolanda Green. Woohoo! Congratulations, Rolanda Green. All right. So Rolanda, somebody will be in contact you via email, the email that you used to register for this, to get some information about which calculator you'd like to have and where to send it. All right. So Mike was sending out in the chat where you can find the links to the recordings. You'll get email with that information as well. And you can have a certificate of attendance for tonight. We'll put the link in the chat, but you can also get this in email. That does it for me. Thank you so much, Tracy and Michael. Back to you.
Thanks so much, everyone, for joining us. This was a lot of fun. Again, I learned a lot, and I really appreciate Tracy's patience.
Oh, I learned a lot too. Oh my gosh. It's amazing how teaching this class, you never stop learning. Oh my goodness. It just gets better and better. If you, there was someone who hasn't been taught it yet. Oh, you try and get a class. You are going to love it.
I agree. Well, thanks so much, everyone. Hope to see you back online soon.
All right. Good night.
Good night.